A lot of people talk about the Internet of Things, which is supposed to be how your oven and your refrigerator send tweets, right? And we actually know about some firewall companies that advertise their ability to keep switch reclosers in substations from sending out Facebook posts. I think, I mean, if you get people to buy a firewall product based on that, fine. But
nobody would ever go onto a control system and use that to browse around and,
If they do, you got some problems. And I will tell you that there are some known cases where the synchrophaser networks, not to get too, synchrophasers are how, in some parts of the country, advanced power systems are managed. All right, and there are some.
You have to keep everything aligned in terms of phase, or they're fighting with each other.
Power factor, right? In parts of the power transmission network. Fascinating subject. But my point about that in this context was the protocol. It's a very latency-sensitive protocol, all right? Because if you have a power factor management problem spanning 4 milliseconds, you got melted copper all over the place, right? So it's a big problem. But there are known cases where they've found in the networks that carry that very latency sensitive traffic, HTTP, that can only be from script kiddies, right? That can only be attack traffic, so it's there. But I like to make a careful distinction when we talk about the industrial internet, all right, of industrial machines that are connected to computer networks that are typically managed by IT organizations. All right, and we like to be very narrow about this, mostly because we're running a business, and so we want to address an important market in a short amount of time that's well focused. And the critical infrastructure, building automation, you mentioned healthcare systems, water systems, manufacturing systems, telephony systems, right, which includes that. Ties closely with financial systems. It's all critical infrastructure, and it's all about machines that traditionally, they do what they do very, very well. I mean, we're all pretty good at engineering and building vehicles and things like that. But it's kind of a new thing, really, over the last 10, 20 years, really, that all these machines are getting themselves onto networks through Ethernet connectivity. For what reason? The primary reasons are secure remote access for diagnostics troubleshooting, and telemetry integration for predictive analytics. All the other.
You didn't mention operations cost reduction.
Well, that's the business driver. Right. That's the business driver. That's why you do the industrial internet applications. But for industrial internet, the way we think about it is machines that traditionally do not have any kind of broad connectivity suddenly appearing on other people's networks. And so the security challenge, the cybersec challenge with regard to that, I mean, the way I look at it, it basically comes down to network segmentation and line of sight enforcement, being able to see what machines are doing remotely but not be able to write to them. All right. And so that gets you into, it's more difficult to your question, right? Because it's a different way to approach cybersecurity than the traditional problems of inspecting network ports and traffic, the internet weather that we're going to talk about shortly. So there are content inspection and awareness of data models that machines use when they speak to each other, which are not terribly complicated, not terribly heterogeneous, but quite distinctive and different from what a lot of cybersec professionals are used to. That's an important part of the problem space.
At the risk of oversimplifying the problem.
That's not a bad thing to do.
Well, I think you bring up a good point. I wanted to emphasize the point, which is, in a typical situation where you have a human sitting in front of a computer and they're browsing the internet, the behavior is going to be erratic because it's a person behind the thing. Whereas in an operational system, a manufacturing system or something, you would expect a more regular, consistent type of activity that's taking place, and perhaps a much higher sensitivity to anything outside of that normal behavior. So
that's incredibly perceptive, absolutely on point. And machines are when humans are interacting with machines, the statistical variance is highly, there's a lot of variables in it, and it's what it is. I mean, there's a huge amount of practice around providing security for those, but when you when you talk about machines, you're absolutely right. I mean, a pressure vessel, it's going to be at 600 degrees all day long and all night long, and if it's ever deviates from that, you take a close look at it. So
you probably want an alarm on that anyway, right?
Exactly right. Well, you've got a SCADA system, but what you worry about now is if the SCADA is feeding telemetry out to an analytics application, is there an aperture for an attack? So, but the point, just to extend your point, which again, as I say, critical for understanding the space. Yeah, each different machine is much, much simpler, all right, in the way it presents to, for instance, statistical analysis and anomaly baselining. But there's tens of thousands of different kinds of machines.
Yeah,
whereas,
lots of different kinds of machines.
There aren't that many different kinds of humans.
Yeah.